Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry will be helpful for the entrance examination and competitive exam on the international floor. In addition, national level JE Advanced and JE Mains for engineering stream for IITs and NITs and NEET chemistry for medical entrance examination, Telangana and Andhra Pradesh MSET examination for engineering stream. In addition to all these, if you are aspiring for any government examination, in that common general studies paper will be there and general science concept will be included in that. In that general science, chemistry content will be given. Whatever we are discussing will be very much helpful. Let's enter into our today's session. Explain the name of following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. Here is the compound. Again, it is the kind of bicyclic ring. One is 6-membered, another 5-membered ring will be there. Both got fused. This is the system said to be fused ring system, right? As per the IUPAC, how can we assign the name for the compound? We will go with. In order to give the name, there are two possibilities. Either you can start numbering from the larger ring side or else shorter ring side. One is 5-membered, another is 6-membered. No, either from 6-membered ring side you can start numbering, or 5-membered ring side you can start numbering. But among these two, the correct representation will be larger ring should be given higher priority first. That's the reason why numbering will be given 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the way you have to give the numbering, and moreover, it is of 9 carbon containing bicyclic system. Let's go with further. How can we give the name for this one? In order to name this one, here one side you can find 4 carbon atoms after the fused carbons, and another side 3 carbons are located. So 9 carbons already known to you. Among 9 carbons, 2 carbons are fused. Fused means they are the part of 6-membered, they are the part of 5-membered as well, right? That's the reason why in this bicyclic fused ring system, we have to go for 1, 2, 3, 4. Apart from this fused carbon, whatever present in the any other side, you have to give 4 for these carbon atoms. And another side, we have 1, 2, 3 carbons. After the fused ring, and the leftover will be 3 carbons. So that let me mention 3. Why it is taken as 0 means, in between these two bicyclic carbon atoms, we can't find any more carbons. 2 carbons are directly joined rather than no extra carbon is linked with them. So that you may take 0. 4 stands for the carbons of 6-membered ring which are free. So beyond that fused carbon atoms. And 3 stands for these are the part of 5-membered ring beyond this fused system, right? And the 0 stands for wherever fused carbons are present. In between, we can't find any more extra carbon. That's the reason why 4, 3, 0 is indicated. And moreover, the compulsory condition, they should be introduced in a square bracket. And being it is the bicyclic, so the name will be started with bicyclo. Bicyclo 4, 3, 0. After this, whatever parent skeleton over here, 9 carbons we already counted. So that for 9 carbons, nonane is the actual name. Being it is a saturated, no double bonds, no triple bonds found in this. So that simply we have to mention nonane, right? So that the parent skeleton will become nonane. The complete name of the system will be bicyclo 4, 3, 0, nonane. This is the entire name of the given compound. So this is the way bicyclic compound can be named as per IUPAC protocol. For question number 1, the correct name will be bicyclo 4, 3, 0, nonane. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. In the lead in the pencil made up of mixture of graphite and clay, right? So here pencil lead is made up of graphite and clay. So here graphite is specific for the pencil lead. Lead is not exactly the lead metal, rather it is the lead made up of graphite. Graphite is the carbon compound, carbon allotropic form. When the percentage of graphite is increased, if you are increasing the graphite content over here, Pencil moves across the paper more easily. As the graphite content increases, movement of pencil is somewhat soft, and it is very convenient to write on the paper. They are saying like this. Here the situation is, which statement explain this observation, right? So graphite has high melting point. Graphite is a form of carbon. Graphite is a lubricant. Graphite is a non-metal. What kind of explanation will correctly represent as the graphite content increases, mobility in the paper and convenience to write on the paper also increases. That is purely because of its lubrication property. Graphite is the lubricating compound. Then, first of all, let's start with why pencil lead is made up of. So what material used in this? Okay, so being graphite is the kind of allotrope of carbon, so that it will impart the black color pigment. It will be so that it is convenient to write on the white paper. But black and white complexation will very brightly represented. That is one thing. And the second is, being it is the kind of lubricating material with the such a kind of hexagonal layered structure. Being it is a layered structure, when you're writing it, it gives the smooth finishing, smooth kind of texture while writing this one, right? So that's the reason why this graphite is used in the pencil leads, right? So this is the kind of graphite you can clearly see. It is the non-crystalline allotropic form of carbon, and pencil do not contains the lead. Lead metal will not be there. Rather, you can find the graphite material in addition to the clay. Clay used to bind the materials firmly, right? So pencil lead to be exact. So pencil lead is made up of graphite. To get all the zeologist on you, what plumbago is a naturally occurring crystalline form of carbon. Plumbago is the kind of crystalline form of carbon arranged in the hexagonal structure. In fact, graphite is under high enough pressure and temperature, it turns into the diamond. It is possible to convert graphite into diamond by applying the suitable optimal conditions, we can say, right? So here is the graphite. Graphite, diamond, both are allotropic forms of carbon only. So this graphite is having hexagonal layered structure arrangement, whereas diamond is having closed packed three-dimensional regular tetrahedral arrangement, that is purely crystalline. This is a non-crystalline texture of the carbon atom, right? So because of this kind of layered structure, and all the layers are bounded with the dotted line bonds. Dotted line bonds are nothing but these are van der Waals forces. Van der Waals forces are somewhat weak in nature. That's the reason why whenever we are applying the force, these bonds are slide upon another. These layers, one layer can slide upon another, so that movement is very smooth. The softer texture we can notice. That's the reason why graphite is having the lubrication property. In addition, it is also having pencil lead, being it is a black color pigment, so that pencil lead also made up of this graphite. So as we are observing over here, powdered graphite used as a lubricant. So as graphite content increases, your ease of writing also more convenient like this. This is the way we can explain. For question number 2, option number C will be the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced 2020 question paper held on 27/9/2020, and it is the part of paper 1 and chemistry content we collected over here, and purely it is the part of organic chemistry and different reagents applied in the starting material. Again, it is a fused compound, benzene fused with saturated cyclopentane. Whenever it is treated with the cyclic anhydride, this is called anhydride, no? Anhydride is treated under AlCl3. This is the Lewis acid. So we can say simply it is the kind of acylation. Friedel-Crafts acylation process is carried over here. P will be converted into Q. And here zinc amalgam and HCl. Zinc HgHCl is called a zinc amalgam HCl. This is a Clemmensen reducing agent. Wherever carbonyl group is there, that will be turned into purely alkyl. So entire carbonyl will be reduced. Powerful reducing agent of carbonyl into alkyl, that is Clemmensen reducing agent. Under H3PO4 acidic condition, certain transformation is possible. We will get a R. After getting this R, any other reagents added RCH3 MgBr, which is called Grignard reagent. Subsequently, hydrolysis is carried, and acidic conditions also provided under warmth condition, warmth environment, so that final product S will be generated. We have to find out what are the kind of compounds generated over here, and how it will be related with the given options, right? They are saying S will be the compound of tricyclic like this, and B in option number B, they are saying Q will be the product where you can find this acyl will be added over here, and this will be the kind of product generated. R will be again tricyclic, but there is certain difference between the S and R among these two. Here you can find a C double bond over here, and remaining will exactly resembling the compound P. Only the 6-membered ring introduced with the ketonic functional group, that is R, they're saying. And D will be, in the option D, they're saying that the final product S will be, again it is a tricyclic ring with the all methyl substitutions, and one more double bond is also introduced. In order to get which is exactly correct for S, RQ, or R, or D, we have to go for the series of reactions whichever carried in this chemical synthesis. Let's take starting material. Starting material is said to be benzene fused with cyclopentane. So this benzene cyclopentane fused compound is having side chains like this is called tertiary butyl, and here 2 methyl are present on the same carbon. If 2 methyl on the same carbon is called gem, and 2 methyl and the adjacent carbon are called vicinal. Okay, this is the kind of gem dimethyl functional groups present. And under Lewis acid conditions, we are adding this cyclic anhydride. Whenever cyclic anhydride is added, it is obvious to go for Friedel-Crafts acylation process. Acylation got carried. This will be opened and will be attached at this position, so that actually here one thing we have to understand. So whenever alkyl substitution will be there, alkyl substitution having natural tendency of ortho-para directing nature. So directing efficiency, everybody aware. Any alkyl group if present on the benzene ring, further incoming substitution will be directed towards either ortho position, sorry, not either, ortho position and para position, because methyl, ethyl, propyl, all these are the part of ortho para directing groups, right? But here typical condition is provided. Tertiary butyl is the kind of bulky group. It is a kind of bulky group, so that it will hinder all the ortho positions. Exactly adjacent positions to this tertiary butyl is called ortho positions. 2 ortho positions are completely occupied by this tertiary butyl, so that these positions are not free for any substitution. And another 2 carbons are in fused condition, so that these 2 carbons also not available for substitution. Only leftover position will be this one, right? So this carbon only available for further substitution with that is this is the kind of ketone. So ketone will be preferably attaching at this carbon rather than these 2 carbon atoms. The reason is here these 2 carbons totally covered with tertiary butyl. Tertiary butyl is very larger, so that it sterically hinders, completely covers 2 ortho positions, so that there is a probability to attach at this meta with respect to tertiary butyl. So this is a peculiar condition we can notice. This is the product called Q. This Q further treated with zinc amalgam and HCl. Zinc mercury combination with HCl is called a Clemmensen reducing agent. Simply wherever ketone is there, that will be converted into CH2. So we can notice C double bond O now converted into CH2. It's a simple reaction only, named reaction we can say. Further, we are adding phosphoric acid. H3PO4 is called what? Phosphoric acid. What phosphoric acid will do? Phosphoric acid will participate in dehydration and subsequently ring cyclization, ring closure reaction get carried. Whenever ring closed, H plus and OH minus removed, so that here we can notice there is a formation of ring closure, that is R product. Our product is ring closure reaction. Later on, let me add Grignard reagent. CH3MgBr is called Grignard reagent. Grignard reagent, when added, ketone is converted into secondary alcohol because of subsequent hydrolysis. So this Grignard reagent able to convert ketone into secondary alcohol, hydroxy. 2-degree hydroxy will be generated. This 2-degree hydroxy, if present, I'm going to add one more reagent called acid, that is sulfuric acid. They specifically mentioned over here sulfuric acid under what warm conditions. So that sulfuric acid is very specific for dehydration, no? So that let me remove water from the adjacent positions. Whenever water removed, here is the formation of in either double bond, that is in conjugation with benzene ring. So that this is the final product, more stable product we got. A cyclic ring with a double bond in conjugation with the benzene, that will be final compound S. These are the series of reactions carried over, and there are so many named reactions involved in this, and we have to understand what is the exact mechanism behind the chemical reactivity of this starting material. So based on this, we have to go for which is the suitable condition and what are the suitable options provided, right? So starting material upon treating with this cyclic anhydride under AlCl3 conditions, we said that this position, meta position preferable for the attachment. So where can you see that meta position is available in this option number B. So that Q product will be meta substituted ketone. That perfectly correct. Q is the correct answer only. So that means B option is correct only. And after getting this one, zinc amalgam HCl and H3PO4, if treated, R will be generated. What they are saying, R is the product generated like this. But it is not exactly similar what we got over here. The product what we obtained, this ketone is adjacent, ketone exactly adjacent to the tertiary butyl. But here, ketone is away from tertiary butyl. This is not correct. This is not right orientation, we can say. Right, so that R is wrong. And move on to S product. Two S products are given. Among two S products, methyl away from tertiary butyl, methyl near to tertiary butyl. This is the correct representation. We can notice it will be in conjugation with benzene ring. So this is the right representation. D is correct. B is correct. D is also correct. You can clearly see here. So B is, this Q is correct, and this is S. S is also correct, which are available in option B and D. So for question number 3, option B and D are correct answers. Multiple answers, so we need to make the correct choices over here. Move on to question number 4. Question number 4 is collected from the coordination chemistry. Inorganic, it is a part of inorganic chemistry. Choose the correct statement among the following. These many options are provided. So we have to go for more than one correct answers will be there. Which answers are exactly correct we will go with. FeCl4 minus, it is a kind of negative complex ion, has a tetrahedral geometry. We have to check whether it is correct or not. Cobalt EnNH3 taken twice Cl2 positive has two geometrical isomers. We have to check whether it is correct or wrong. FeCl4 minus has high spin only magnetic moment. Then cobalt EnNH3 Cl2 positive. So here high spin is possible for this one. High spin is not possible for this one, they are saying. The cobalt ion in the cobalt EnNH3 taken by Cl2 positive has sp3d2 hybridization. sp3d2 hybridization is possible for this molecule, they are saying. Among all, A is correct one, C is also correct one. We have to see why B is not correct, why D is not correct. Let's check about all the things whichever mentioned. Whenever iron Cl4 minus is taken, first of all, we have to write its electronic configuration of metallic iron. It is the part of D6 system, right? 3D6, 4s2. But in this FeCl4 minus, it is existing in the oxidation state +3 around the central iron. Fe +3. So pull 3 electrons from this. 3 electrons we need to remove, s electrons, and 1 d electron if removed, That will become 3d5. Fe plus 3 is 3d5 system. 3d5 if present, s orbital 0, p orbital 0, all vacant orbitals got mixed up, which is sp3 hybridization. sp3 hybridization gives rise to tetrahedral geometry. What they are saying perfectly correct. Move on to option B. Cobalt En NH3 taken twice plus have two geometrical isomers they mentioned, but in practice, three geometrical isomers are possible. How can we say? Here, En is the part of chelating ligand. Chelation is nothing but if ligand is having two sides attachment with metal, so that it is a cyclic compound. Cyclic compound will be formed like this. And here is the possibility. You can clearly notice En is taken like this. If chloro or in the opposite side and NH3 on the same side, this is one type of orientation. Just to replace NH3 with Cl, so that this is another representation. If two NH3 and two Cl are taken in the transposition, this is another representation. So that for cobalt En NH3 taken twice positive, you can find three probable orientations, so that we can say three isomers are possible, and these are called what? Geometrical isomers. Why these are called geometrical? Geometry, there is a change in the geometry is a possible because of position of ligand. Ligand position got changed, so that three possible geometrical isomers we can notice. Move on to option C. So option C, FeCl4 minus is sp3 hybridized, and chloro is a weak field ligand, so that it will participate in the spin only what spin only magnetic moment. But in case of cobalt En NH3 taken by Cl2 positive, strong field ligands are present, so that spin only orbital contribution will also present, so that whatever they are saying, not if he is a high spin, so here chloro or weak field, whenever weak field ligands are present, the complex is said to be high spin. But in case of cobalt En is the strong field ligand. Whenever strong field ligand is present, the strong field ligands will impart what? Low spin complexes. So that we can say FeCl4 minus is the high spin complex, and cobalt En complex will be low spin complex. There is a difference. So that C, whatever they explained, exactly correct. C is correct only. Move on to D. What they are saying, cobalt En NH3 taken twice, Cl2 positive has D2sp3 hybridization. Being it is the low spin inner orbital, D2sp3 is called inner orbital hybridization, D2sp3. sp3d2 is the outer orbital, d2sp3 is the inner orbital hybridization. This is exactly correct. Okay, so for question number 4, option A and C are the correct answer. Because sp3d2 they mentioned, sp3d2 is not possible. In practice, there is a possibility of d2sp3. d2sp3 is the required one, but explained one is sp3d2, so that D option is wrong. So FeCl4 minus is having tetrahedral geometry. This is correct only. Cobalt En NH3Cl taken twice, Cl2 positive, two geometrical isomers are wrong. Three possibilities we have. FeCl4 minus has high spin, correct, and cobalt En having low spin, correct. So C is also correct. But D2sp3 is the possibility, but they mentioned sp3d2, so D is wrong. So among all, A and C only correct answers. For question number 4, A, C is the correct answer. Move on to question number 5. Question number 5 is collected from Telangana Gurukulam Degree College Entrance Examination. Select the correct statements with regard to Nernst equation for the concentration cell. Right? It is a part of electrochemistry. Electrochemistry deals with the chemical reaction, how it is related with the generation of electrical current. Right? So concentration cell is the part of galvanic cell where either electrodes are similar and electrolytes are similar. Okay, two electrodes, in order to construct the galvanic cell, we need to take one anode, one cathode, and their subsequent electrolytes are required, right? In case of concentration cell, we have to choose two electrodes of similar composition. two electrolytes also the similar composition, but only the difference is either electrode concentration can be varied or else electrolytic concentration can be varied. This is the way concentration cell will be constructed. According to Nernst equation, for the concentration cell, what they are saying among all four options, one is only the correct statement regarding this one. Right. Nernst equation has E naught for both concentration cells with and without transference. Wrong. E naught will not be there. E naught denotes a standard electrode potential. For concentration cells, E naught value will become 0. So what they are saying is not correct. The Nernst equation has no E naught for the concentration cells without a transference, but has E naught in the case of concentration cells with the transference. This is also wrong one, because all concentration cells E naught value, standard electrode potential value will become 0. Okay. The Nernst equation has no E naught for both the concentration cells with and without transference. Exactly correct. But has junction potential in the concentration cells with the transference. We will explain about this one. The Nernst equation has no E naught for both concentration cells with and without transference, but has junction potential in both the cases. Right. This is also wrong one. We have to explain about why this option number C is correct answer with respect to Nernst equation for concentration cells. Right. In order to explain that one, first of all, we have to see what is concentration cell. Concentration cell is the electrolytic cell. It is composed by two half cells. Two half cells are having same electrodes but differing in the concentration. Two half cells are having similar composition but concentration will be differed. That is called a concentration cell. A concentration cell acts to dilute more concentrated solution, concentrate more diluted solution. So if diluted solution is there, you can make it concentrated one. Either concentrated solution is there, you can make into diluted one as well. So that both the possibilities we have. Concentration matters in case of concentration cell. Composition remains constant. Composition remains same, but concentration will be varied, right? So the first condition what they are saying, E naught for both the concentration cells will be 0, because E naught, just to be said, E naught is the standard electrode potential. That E naught will become 0 in a concentration cell because all the solutions are having 1 molar, for example. No concentration difference will be there. Only the difference is sign convention difference. Okay. Both the half cells having equal composition. No. The standard electrode, for example, I'm taking two half cells made up of hydrogen only. One half cell electrode potential is hydrogen. We can't make +0 -0, right? Let me go with another concentration cell which is made up of zinc. For example, zinc concentration cell I am taking. So one half cell is made up of zinc dipped into zinc sulfate. Another half cell also made up of zinc dipped into zinc sulfate. One half cell of zinc is working like a oxidation. That means cathodic half cell. Another is an anodic half cell. For example, cathodic half cell, itself it is having negative charge over there, and it used to release the electrons in the electrolytic cell, so that whenever electrons got released, so that minus 0.76 volts is given for zinc. In another half cell, it accepting electrons, so that plus 0.76 will be there. In one half cell, minus 0.76. Another half cell, plus 0.76. So that final E naught will become 0. That is cancellation of both the standard electrode potentials, being it is made up of same type of composition. That's the reason why for concentration cells, we can't assign any E naught value. And junction potential. In order to explain about junction potential, how can we construct the concentration cell? Again, we are observing. As the cell as a whole strives to reach the equilibrium, the more concentrated half cell to diluted half cell, always movement of electrons are possible continuously. So higher concentration to lower concentration, it is possible. Its a concentration got increased. Wherever lower concentration there, slowly its a concentration got raised via Transfer of electrons between the two half cells. So transfer of electrons are possible from high concentrated to low concentration until this concentration dilute also got whose concentration also rises and both are getting equilibrium, right? Whenever these electrons are flowing from one to another, so there is a kind of junction in between, and the potential generated between the two junctions is called a junction potential. That is also possible for this concentration cell. So what they are saying in the option number C is perfectly correct. One is E naught value will 0, and second, junction potential is possible for concentration cells. For question number 5, option number C will be the correct answer. Move on to question number 6. Last question of the session. Read the two statements A and B carefully. Select the correct relationship between them. Okay. Two statements are provided. We need to assign which statement is correct, which is wrong, or both are correct, or both are wrong. Entire one we have to describe. The more the concentration of strong electrolyte, more is its conductivity, right? So as the concentration increases, conductivity of the solution also increases. Concentration increasing is nothing but more the number of ions. Greater the number of ions, obviously conductance also greater. So that option A is perfectly correct. Equivalent conductance of strong electrolyte increases with its concentration. Equivalent conductance increases with its concentration is correct statement only, but here is the logic. Strong electrolyte they mentioned. For strong electrolyte here, as concentration increases or decreases, it will not depends upon its concentration. Okay, for strong electrolytes, if it is weak electrolyte, so if this is the case with the weak electrolyte, whatever they are saying perfectly correct. So that statement A is correct, but statement B is wrong. Okay, so option A is exactly explaining what they are mentioning. Let's see in detail explanation regarding this question number 6. In order to explain, they are saying strong electrolyte. No, let me take the salt solution over here. Salt solution is dipped with one anode in either cathode over, and it is connected with the external circuit so that conductivity will be tested. Okay, whenever strong electrolyte like salt will be taken, I am taking sodium chloride salt. Whenever sodium chloride salt will be taken, let me add some more salt to this one. What happens? More the sodium and chloride ions will be released over there. That's the reason why more number of ions will carry more the amount of current with them. So conductance will be raised. This is the case we can clearly see in the option A, right? Strong electrolyte, as the concentration increases, conductivity also increases. Okay, this is in the case with the free conductance of the given solution. So move on to option B. Option B, they are saying about equivalent conductance. Equivalent conductance is denoted with kappa, and this equivalent conductance is defined as kappa is equal to K into 1000 by N, right? So K is the specific conductivity, 1000 by N denotes a normality, right? So lambda is equal to K into 1000 by N will be taken. This is the formula for equivalent conductance. The definition of equivalent conductance is number of equivalents of electrolyte present in 1 liter solution. Its conductance is called equivalent conductance. Okay. Here K is the specific conductance, N is the normality of the solution. This is the way equivalent conductance can be explained. Here is the condition strong electrolyte. This is the logic in this option B statement. Okay, strong electrolytes, whenever they are in water, what happens? So they completely ionized. 100% ionization is possible. Still, you're adding water to that one. Though you're adding water, there is no further ionization because being it is a strong electrolyte, whenever you're adding, for example, 1 tablespoon of salt is added to the water, no? So 1 tablespoon of salt is added to water. Salt is 100% ionizable. It will be converted into Na plus and a Cl minus. Whatever you added tablespoon, entirely converted into Na plus and Cl minus. There is no NaCl as such. All converted into Na plus Cl minus, so that number of ions are same. Sorry. If you are adding one more glass of water to that one, though you're adding one more glass of water to the same container, there is no increasing the number of ions, because already entire sodium chloride under ionized form only, being it is a strong electrolyte. Electrolyte will be completely ionized. So addition of water will not impact its further conductance, because no increasing the number of ions, no, so that no increasing the conductivity as well. That's the reason why whatever B statement is not correct, but A statement is perfectly correct. For question number 6, option number 1 is the correct answer. By this, we entirely completed. This is the example regarding, they are taking KCl. So potassium, being it is the larger cation, it is mentioned with this kind of purple ring, purple lobe, and the chloride is represented like this, and it is in water. So these entire bent molecules are said to be water, right? So here K plus and Cl minus ions are like this. They are represented. They are completely ionizable. It is also the kind of strong electrolyte. KCl is also the kind of strong electrolyte. Whenever you're adding KCl to water, K plus completely formed and Cl minus is also completely ionized. This is the way you can clearly represent, right? So by this, the entire session got completed, where we discussed about all the different dimensions of chemistry entrance, in what way the weightage will be there, in what way the question if given, and what is the analogy to solve them. Different kind of concepts are covered over here. I hope this session will be really informative for you, and I'm sincerely requesting to like the channel, comment which is really interesting for you, and share with the aspirants who are seriously preparing for the examination. Subscribe the channel in order to receive more such updates. And thank you very much for your patient listening. Thank you, one and all.